This is the lesson for 7.1 on correspondence and congruence. The learning objective for this lesson is I can define congruence and recognize when triangles are congruent. So with that, we need to know what congruence is. And this is a word that we did talk about last unit, so hopefully you remember it. Congruence refers to whether or not a figure is the same size. Two shapes are congruent if they're equals and are congruent and their corresponding sides are congruent. We're going to come back to this one in a minute. So that is basically an 8th grade definition of congruency. So in 8th grade, we talked to you guys about congruent triangles, and they are congruent if all of the angles are congruent to each other and all of the sides are congruent to each other. So for example, we would give you like this triangle here, and we would say, okay, so there's this other triangle over here, and we would say, okay, this one is the same as this one, and this one is the same as this one, and this one is the same as this one, and also this is the same as this is the same as this, and this is the same as this side. Okay, so if you had all that information, you could say they were congruent. So the reason for that is corresponding angles and corresponding sides. So let's talk a little bit more about what corresponding means and what that is. So we're going to go down here in the corner. The angles that match up to each other are called corresponding angles. Okay. The sides that match up to each other are also called corresponding sides. So let's start with our corresponding angles. So if this angle is the same as this angle, we could mark it like this and say those are corresponding angles because they're in the same little top corner here and they're the same side. So they're corresponding because of their position. They're congruent because they're the same size. Same with this one. This angle right here would correspond to this angle. Now these markings actually do tell us that they're equal also, so they are both corresponding and congruent. They're corresponding because they're in the same spot. They're congruent because they're the same size. And this angle over here would also be corresponding with that one. Now, sometimes it's kind of hard to tell which angles are supposed to be corresponding to each other. So you have to be really careful about that. So the orange one here, the orange one is the easiest to tell because it's kind of this long, pointy angle. So it's easier to tell over here that the long, pointy one is supposed to be this orange one. Okay? So once they've been kind of moved around, it's a little bit trickier to tell, but there are still ways to do it. So that one's easy. The others are a little bit harder. So the red one, see if you can figure out which angles would correspond with the red angle in these two triangles. See if you can figure it out and go ahead and mark it. It is this one on that triangle and this one on that triangle. The easiest way to see that is if you were to take these and kind of tilt them a little bit, it would match up with this one. So that's one way to look at it. Or if you keep rotating it, it would look at that like that one. And by process of elimination, we know that this is the blue one. But same thing, you could tip it and look at it that way to be able to tell. Okay. So those are our corresponding angles. Okay. So we're talking about them being in the same spots for them to be corresponding. They match up with their spots. So the next thing we need to talk about would be our sides. Sorry, our corresponding sides. So with our corresponding sides, we look, and corresponding would be this side over here on the left matches up with this side over here on the left. Now again, once they've been flipped, it's a little bit harder to tell, so you have to be really careful. How do we know where the pink side should be on these two triangles? Go ahead and see if you can figure it out. Okay, so the pink side should always be the one that runs between the blue angle and the red angle. So that's how we know those are corresponding, because they run between the same angles every time. So if we did the purple one, it's pretty easy to tell on this one. It's the bottom one, right? The bottom one and the bottom one, those match up on their spots. Gets a little trickier to tell on the other ones because they've been turned, but it's always going to be the one that runs between the blue and orange. So it's going to be there and there. And then the last side, again, it's pretty easy to tell when it's the last one, but on this one it would be like the diagonal up here at the top and here. But it's also always going to be the one that runs between the red angle and the orange angle. So it's also going to be those two sides. So hopefully that helps explain what corresponding is. It's the spots that match up, okay? Now these angles these lines and angles are in the same position in relation to the rest of the triangle. For example, and I'm going to say the pink line is always between the red and blue angles because they are corresponding sides. The pink lines are always corresponding sides with each other because they run between the red and blue angles. Okay, so that is one definition of congruence. So that's a very quick recap of what you should have learned about congruence in 8th grade. There's also another definition that we want to add to that this year. Two shapes are also congruent if a series of transformations can carry one figure onto the other. So when we say it can carry one figure onto the other, that's like saying if this is your pre-image and this is your image, and we transformed it and it landed right here, right on top, then that's being carried on to this other shape, okay? That's what we want to have happen in transformations usually, and that is a way that we know things are congruent. So if you take something and you do basically anything but a dilation to it, it's going to stay congruent. So we're going to look at this picture and we're going to say which shapes are congruent to each other in this image. So take 10 seconds, figure that out. Okay, in most of my classes, they figured out A, B, C, and D pretty quickly. Now, I pushed them to make sure that you guys understand why are these congruent? Why are A and B congruent? So the reason is because if you take A and you reflect it across the y-axis, then you get B. That is a transformation. That's a series of transformations that carries A onto B. So if you can do that, if you can carry A onto B, then they are congruent. The formal notation for that would look like this. A is congruent to B. They also said in class, though, that C was also congruent. And I pushed them again. Why? Why is C congruent? Well, you can take B, you can rotate it, and end up with C. That's a transformation. So B is also congruent to C. And I pushed them more and said, well, but aren't A and C also congruent? I said, well, yeah. I said, how do you know? This is where the series part comes in. So series means more than one. So if we reflected it and then rotated it, we would go from A to C. That's more than one transformation. That's a series of transformations. So A is also congruent to C. And they also figured out this one is also congruent to D because you can go and just translate it up and to the left. And I want to make sure you guys know this. So A is congruent to C, A is also congruent to D, and B is also congruent to D. These are all congruent to each other. So this is fine. You can just write it just like this. But I want to make sure you guys realize that if that's true, they're all congruent to each other. Because if A and C are both congruent to B, then they also have to be congruent to each other. Okay? All right, last thing for today, we just need to talk about a couple symbols. So, pick good colors here. I'm going to come over here and we're going to label this just for the sake of talking about some of the symbols. It might make it easier. So I'm going to label that as ABC. So we have kind of two ways that we could write angles. We could just write like angle B, and that's fine. Sometimes we have to be more specific, okay? And we could write angle ABC. So if you come over here and I say angle ABC, which angle am I talking about? Well, these are directions. You go from A to B, B to C. The angle that you're talking about is the one in the middle. Okay, the vertex is always going to be in the middle of those letters. Okay, and then I also want to make sure you guys know the difference between angle ABC and triangle ABC. So angle ABC, as we just talked about, is just this angle right here. Just this angle. But triangle ABC is the whole shape. So this one is just talking about the angle. This one is talking about the whole shape. Okay. All right, next, line segment. So a line segment is different than a line because it stops. So lines go on forever and ever and ever and ever. And so we put arrows on them. But sides of shapes just stop. So this is what we call a line segment. Okay. The way that we write it is usually with the two vertices that it connects. So like, for example, line segment AC. Sorry, I meant AB. So it runs from A to B. We're talking about this line segment right here. Okay, that's how we write it. Parallel, we write like this. They're just really tall letters, really tall L's basically. We just draw two parallel lines. Perpendicular is really similar. We just draw a perpendicular line. It's like an upside down T. Okay. The symbol for congruent looks like this. We've already used that today. And then I also wanted to show you the symbol for similar. Looks like that. The reason I wanted to show it to you is because congruent takes that shape for similar and adds an equal sign to it. So congruent things they are similar, they're also equal. That's where this symbol comes from. So we won't talk a ton about this year. You guys will get to it a little bit more in 10th grade, but I did want you to see that this symbol does relate to other symbols. Okay. That should do it for 7.1. We did also start 7.2 today, so make sure you watch that video also.